Okay, guys. So open the file, go through the indices. And then, okay, and then we need to do what? We grab the line, we write the line with the new line here. With the new line. Alright guys, back. Sorry, my battery died, so I had to quickly turn everything off, stop the recording and trigger a new stream. Okay, so here we are. So I'm writing this, and now we have to grab this index and find the source that's paired. So in all reality, what we just need to do here is grab the ones that are paired with Latin first. Just a second. So target path, output path, Latin, 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 target Latin. We need one more here. We need this as well. And we need here the Cyrillic ones. Source paired with this. And then here lines and indices. And then English lines and indices. And then I just grab this. And basically we index into, we grab the English line by doing this of I and then 0. And we also assert, well, let's do English tuple, line in English line and index. And then we grab the English line, oops. We grab the English line by just grabbing this, and then English index is this. And then we assert that the English index is equal to this index. And only then do we write. And we write to F, and we write to also English line here. This should work. This should be everything we need. It's kind of messy, but I'm gonna fix it to make the logic super transparent and easy to understand. Are you guys here, by the way? Interesting? I don't see you. We lost all of your, we lost all the chat messages. Yeah, awesome. Cool, cool, cool. Okay. Sorry, I had to focus. It was very hard to see your solution as well in parallel for this particular scenario. So after this, we have 4 new files in the same root. So we next up need to delete the original files and then grab the Latin and put it into a different directory and Cyrillic into a different one. But that's going to be the second pass after we do this for the whole corpus. I think this already should work. We can do better, but it truly does not matter because the complexity is so small that it doesn't really matter. Even for 100 million sentences, it would be considered over engineering. And as somebody says, I think, was it Linus or someone, that's the root of all evil. Over optimization. Donald Knuth. Okay, fair enough. That guy knows a thing or two about algorithms. Okay. I think this makes sense. Let's quickly. Okay, we first need to rename some variables and just make sure that this is a bit less messy. Let's step through this. I think that's the best way to do it. Let's just step through this and start doing it. So root directory, let me specify it here. For now, let me just put this as false, and let me just specify the root directory directly here. I'm just gonna hard code it like that. I think that's actually correct. And let's just go. Let's see what crashes, what doesn't crash. Run this. Okay, grab the root. We walk until we find the first path, and this one is English Latin. We assert that there is one, and we find the Cyrillic. So we're currently handling the XLN dataset. And so here is the structure. The name of the dataset is here, and then the language direction, English Latin to Serbian Cyrillic, and then we have two files. So now the thing is, even though this says Serbian Cyrillic, inside of it are both Latin and Cyrillic scripts. That's why we're trying to split it down into two separate ones. So let's grab the source file, which is going to be the English Latin, and the target file, which is going to be the Serbian Cyrillic. Okay, build the paths, and we say, okay, we're processing Serbian Cyrillic file. That's so far so good. Couple of variables here. Let me see the names. Target language, target Latin lines and indices, and target Cyrillic lines and indices, and then Cyrillic indices and Latin indices. Okay, let's see. So we open up the target file, we read the lines, and now we go through the lines, we prepare them, we count the Cyrillic. Depending on that, we keep on appending to the above two structures. And then we do that. And after we are done with that, we basically have, we need some progress bar here. Let me add some progress bar. So I'm going to import from tqdm, import tqdm, and then wrap that up in tqdm. I'm not sure whether I can do it like this, enumerate, and then will this work? I'm not sure, but let's try. Oops, that's actually wrong place to put that. We wanted to do it where? Here. tqdm. You think it's before the enumerate? I don't think it's before. I think it's like this. If you do it before, enumerate is a special. I think, let's see. Let's just test it. I'm fairly sure it's like this, but we can quickly change it if not. Run. Yes, it seems it's working. So we get the I0 and line, and we have everything already here. So processed, we split, and then we can continue. So we can now follow the progress down there. Nice and neat. And then we need to find the source that's paired with the Latin lines and the source that's paired with the Cyrillic lines. Because this was the target Latin lines and target Cyrillic lines, we need to find the source. And then we're going to read the lines. Again, here we have to add a bit of tqdm magic. And then if this index is in the Latin indices, we could have done everything in the same structure. Again, those are micro optimizations. It doesn't really matter for this code because, as you can see, the bottleneck is actually in this processing there, not here. So if it's in the Latin indices, then we add that line here, including the index. And we keep on doing that here, and we have to be either here or here with the indices. Okay, once that's done, we create 4 output files. We have the target path in Latin. We won't see the tqdm because I didn't add it. But it doesn't matter. It's actually okay. It's actually fairly fast because here we were not doing any processing. Okay, that's cool. So target path is this one. And then we have English coupled with that. That's kind of weird. Let me see what we can do here. So target path, this is where the Latin part of the Serbian script will go. The previous name was, what's the name of this file? It looks like this. We should grab what we should do is grab the corpus name immediately by grabbing the target file, splitting and grabbing 0. So that's how we grab the corpus name. It's always going to be in that format because I forced that format throughout the code base. So then we actually want here target path to look like, let me think. We want to have corpus name dot this, and same for every other one, but then we need some prefix just to make sure it's clear what's going on here. So we have corpus name, source lang, that's all nice and fine. Here as well, corpus name, here as well, corpus name dot. Okay, and then above our Latin here are Cyrillic, but now in order not to override the original files, we need a prefix. We can just put the prefix like temporary, literally just temporary. So just add temporary everywhere, so we don't override the original files. Okay, and now that we have this is not good. This is good. Let's just see the names here. The names are kind of annoying. Target path Latin. So what does that even mean? Target path Latin. So that's I'm gonna do something like target data path Latin, target data path Cyrillic, source data path Latin paired, and here source data path Cyrillic paired, something like that. We're not removing any indices, that's the thing, we're just shuffling them across different files. Okay, and now we go target file path, source file path, target lines and indices, source lines and indices. This now looks better. And we do what? We open both the target as the target file, and we open the source as the source file. Let's rename it a bit better. And then we go through the lines from the target, which can be either Latin or Cyrillic. We grab the source line that's paired with it, this is going to be the source line and index. And then we get the source line, we get the source index, we make sure that the source index equals to the target index, and target line, whoops, no, target index here, target index here, target index here, and make sure this is called target line. Okay, now let's just make sure we fix this. So target line, target index going through there. We pick the target line, source line, and the source index. They are coupled with the target index. We make sure they are the same, and then we write them to target line to source line. That's it. This is not filtering. This is more classification than filtering. Okay, so is there any way we can mess up the pairing here? We need a parallel corpus after all. So we did note which lines they came from the Serbian file. Now we have the English file. We use this logic here to split to find which index, okay, which index is here, and then in order to pair it, this should be good. We should make a couple of asserts here, like one assert is that the length of the source paired with Latin lines should be equal to the target Latin lines. And we should do the same thing here, just to make sure we are not messing up the parallel corpus. Cyrillic lines with the target Cyrillic lines. And also indices should be the same. Grab the line, find the one that's coupled here. Now guys, this will not work. This will not work, it's gonna crash here. It's gonna crash here because the original indices here that we're saving here are coming from the original file, which is much longer. Then let me see here, this is gonna work. This is going to work, but here this will not work. So we can't index using this index into this. We have to add a offset. We have to subtract the offset if we are about to do that. So let me think for a second. We probably need some dictionary or something. Let me just see what's the best way to do this. There is a bug here that I noticed before even running it, which is good. Let me think. Yeah, makes sense. We can put this in the same loop. We can put this in the same loop by just opening the file up there as well. Is that what you're saying? We can do that. We can do something like this. But that's again more refactoring thing than anything else. So we can do something like this. And then let's see. We go through the target lines. We prepare it. Thanks. I'm gonna fix that. Let me just see. Cyrillic counter. So here we append it here, and then we need to iterate through both. We need to go through the zip here, right? We need to go through like a zip of source lines and target lines. And then we have a source line and the target line. Well, we prepare the target line. And depending on the target line, we append, we can basically append everything here, right? That's the best way to do it. So like just grab the source line and immediately grab the target line. We don't even need indices. That's correct. That was a good tip. 100%. I think this is going to be much easier to parse through than anything else. And then we don't need anything here. That's going to be much easier. So we open up both files, we read the lines, we take the target line as the discriminator, and then we just map them, and now we're sure that this is still the right data set. And we don't need the indices, we don't need this. And then we just create these output files. Yes, we don't need them. And then we go through here. This is much better. Awesome. Thanks a lot. This was helpful. Again, teamwork. And let's see. Now that we want to write this out to output, we don't need all of this. We just need the paths. And we need one of these. And then we just open. We grab the It's going to be a source line. Something like this. Something like this. Target file path, source file path, and then the lines and indices. That's much better. I think this is much cleaner. We don't even need now the enumerate, which means we don't need this, which means we can do just this. Okay, I think that's not good. So now we go through the Latin and we go through the Cyrillic. We open the Latin, we go through the lines and we just thumb them. And we do the same for Cyrillic. This should work, right? I think it will. Here we can probably add PQDM as well. Wherever we have these longer loops, we can loop like that, and that's it. Awesome. Let's try this. Rerun. Rerun until we get here. Collect the data. Why is it not printing? Yeah, we're gonna walk step by step. Why don't I see? Why don't I see progress? Why don't I see the progress here? Oh, I think zip is messing it up. Let me just see. I think zip is messing it up here. We need to add total. Something like this should work next time. Thanks. So here's the last one. Here's the last piece. So it's as simple as this. You have English and Serbian Latin, and you have English and Serbian Cyrillic. So you go through those two outputs. We start with, for example, we start with Latin. I think we start with Latin, yes? So let's look at this now. Take a look at the output here. We open those two files. We iterate through the lines. And these lines are now going to be the Latin ones. And so we just write, until we get to here again. Okay? And so at that moment, we have two temporary files here. The English one, of course, it's messed up because we added one more new line, apparently. And we have the Serbian Latin one. It's just messed up because I obviously added a bit more lines than I should have. And then we just end up here. Let this run. We create Cyrillic files. And we are up there. And that's it. That's the first dataset processed. So here's the Cyrillic coupled with English. Yeah, let's see where that surplus came from. Let's stop this. Let me delete all of these temporary files. Let me just go grab some water. I'll be back in a second. Okay. This is the usual parallel corpus format. It's called Moses, I think, this format, where you just have lines in parallel, that's it. No special, there is no need. Everything else would be too much. This is the easiest format. Let me just see. Okay, so I added a line here. So we don't need this. Why don't we need it? Because we go through lines and indices. Those come from here. And those are what? Those are just lines that we grab from where? From here. And those are just the read lines. So they already contain. Got it. They already contain the new lines, so we don't need this. Let's rerun. Let's see. So as you can see, they already have the new lines. Let's run it. We see the progress, that's good. Let's get all the way to here. It's running. Okay. This should now work perfectly for the whole corpus. And then in the second pass, we can just use those files and organize them as we need. I think that's all we need. Let me see whether something is happening in Discord here. Okay. Nice. Let me just reply to Chris here, who is our friend from Luther AI. Okay. Continue up here, and let's see the output. Here is the Latin, here is the Cyrillic, here is the English. So let's open up English. Oh my God. So we rebranded English to English Cyrillic. English Cyrillic, okay. Fun. I think it's fine. It's maybe fine for this intermediate step, but let me just open it. Let me just open it here and here. Split this. Grab the English Latin and the Serbian Latin. Split it on here. And then we have English Cyrillic. Okay, so these should be now aligned. Let's just double check on a couple random locations. 237699. Four 40418. Seven 98944. Okay, looking good. Oops. Yep, it's aligned. Really? I don't know how to do that. If you know how to do that, let me know. I only know how to scroll one by one. Okay, that's good. And then I suppose English Latin will be the same, and Serbian Latin. Seven 3229. Two 41413. We'll have to filter out some of these words, but that's gonna come later in the filtering stage using some language ID model 298747. And then at the end here, there is a ton of low quality data here. Nine, 8. Okay, this is misaligned. I think it's also misaligned. Eight, 9, 1. Let's see the original file for a second. 1472. Let's open it up here. One 472-945. Hindu, Hinata. And same here. Hinata. And here we want to open up this Hindu. Okay, it's messed up, but it's messed up in a consistent way. We didn't mess up anything ourselves. That's important. Aha, right click on the select file and click on select for compare. You mean like in the tab? Or on the file actually, like here? Or just here? You mean like git compare or what? That doesn't make sense though. Okay. Left. So I like select both or what? Aha, compare selected. Oh, that's cool. Let me try. Compare selected. So what do we get if we do that? It's kind of slow. It seems it's very slow for now. Why is it so slow? Yeah, I'm gonna just cancel this one. Just select one and then select for compare. And then this. And then select for compare. I think it's literally doing comparison. We don't want to do that. Yeah, I think it does dip as well. I think it does dip. Okay, guys, this is it. Let's just kick it off. Let's just finish this for the whole corpus. Let's see how it progresses. Ubuntu, let's just see where everything goes well. Okay, we have Serbian, Cyrillic, and Latin. Some of these are terribly mixed up. Some of these are terribly mixed up. But it is what it is. Okay. We're gonna run that for Bosnian as well. While that's being done, let's just go and add the second pass. So in the second pass, we go through all of these and we merge them together. That's going to be the second thing we do. What else we have as a to-do? By the way, guys, I don't know if you saw this. I have a task for you. If you want, you can check out this task I made up here. I actually created a GitHub task as well. We're trying to understand why some of the corpuses that we are using, some of the corpora we are using, have these spikes. And this is a histogram of the line length. So let me just open up the GitHub. I added this as a good first issue. So if you want to play with something, this might be a good a good task to play with. Here's the issue, and here's the description, how you can get started. It seems somebody already wants to do it, but you can do it in parallel as well if you want to play with it a bit. So let me just okay. I pasted the link. Let's go. What do you mean by faster? Tokenizer. Okay. What are the next to-dos? Yeah, we didn't do this. We're almost done with this. Let's wrap up these 3 tasks. So let's wrap up these 3 tasks. Let's wrap up the Cyrillic versus Latin, and then let's wrap up the dedupe analysis, and then we can discuss potentially training a tokenizer. Understand why we have line length spikes in the histograms. That's a community task. Okay. We have a filtering pipeline. Check out the getting started document. That's a great place to understand the pipeline a bit better. That's why I wrote it down. Let me show you. Go here to open NLLB, go to the getting started, or just here, you'll find the getting started guide. And then you can find all 5 stages of the pipeline. And the one you care about here is in particular filtering. So you can check that out. Okay, let me just run this. So just check out the filtering stage and what it does. And there are additional readmes there. So here's the readme for filtering. Hope that helps somewhat. Until then, let me see what we want to do now. Now we want to, at the very end here, add a function that's going to walk, grab the temporary files, find the Cyrillic ones. Let me think for a second. Okay, let's do this. Might not make sense just looking at the name here. but it will make sense soon. So we do OS walk. And we do what? I guess we do similar checks here. If the length is 0, then we continue. Otherwise, we assert that we have exactly 6 files. 2 original ones and 4 that we dumped. Well, maybe some won't have Cyrillic or Latin or whatnot, but like, I think this is a safe assumption. Unless the dataset is super small and maybe it's completely Latin or Cyrillic. Okay, so that's again 2 original files plus 4 temporary files. So now we want to grab see what's the root directory. Understand whether we are in the Cyrillic or Latin language direction at the moment. We do that by grabbing the corpus name. Actually, we can just grab the root directory and grab the base name to get the language direction. So we can do something like this. Language direction is going to be this was path base name, and then once we have the language direction, we can split it, and we can just ask, is Cyrillic inside of it? Is Cyrillic can be if that's the case, then we're in the Cyrillic. We grab the Latin files. Okay, let me see what we can do here. Find the Latin files. Temporary files. If they start with temporary. Assert we have 4. Split into Cyrillic files and Latin files. And then we are always going to, let me just see one thing. We always have, for the data, Serbian, for example, we always have the Cyrillic one here. Sometimes we have both. Sometimes, like in Makoku, we have both Cyrillic and Latin. For Bosnian, it's the opposite. It's always Latin. It's always Latin. Okay. How can we make this extensible, generalizable to both Bosnian and Serbian? So we separated the files, but we don't want to pick up both of them. We want to be a bit smarter. Actually not. Let me see. doesn't matter. Latin is always... Okay, I'm gonna do it like this. I'm gonna assume we pick up the files here. This is not gonna work. Just thinking for a second here. What we want to do is enter only, we never want to enter into the both directories. So if we exit above, okay, let's track the ones we've visited already. Okay. So if we've already been, I'm gonna just track, like almost like with graphs, I'm gonna track a visited set. And once we are here, we do the following. To the visited set, we add not just the root directory, but we also add the other language direction if it exists. What I mean by that is we backtrack, go to the parent directory. It's gonna be ospath join like this, and then we find this, and then we do the list directory. Child directories are what? Yes, but we need the absolute paths. We need to do we need to do OS path join here of the parent directory with the child directory. This is actually going to be parent directory path. We don't need this. We can just do this and this, and then to visited we add both of these. Can we just again assert this? The length of this needs to be smaller or equal to 2. And then we go for child we just add this. And now we do the following. If this isn't visited, we skip it. Otherwise, we assert, we find the parent, we find the child directories. These are actually child directory paths. Oops, good. Okay, here it is. And we add them. And now we are here. Okay, so you realize soon what I've done. It might be a bit complex, but it's not. And now that we have this, now let's just grab all of the different files and merge them and place them where they need to be. And now we don't need to track where we are. We always need to have two different, let me just see. Source language, target language, ISO 63913, and here as well, ISO 6393. For example, I might change that code. We'll see. So So now we want to make sure we have both. We want to make sure we have both directions. So we have language direction. Latin. It's gonna be something like this. So English, Latin, Serbian or Bosnian Latin, and then there is a Cyrillic. And this should be, again, we need to assert that this is always English. We just have that assumption for now, because that's how we are building this. Assert that this is English. Okay. And now build the paths out of those. How do we build paths? By taking the parent dir path. So we just do like this, and here as well. And then we make directories. Make directory. Exists okay. Here as well. Whoops. Exists okay, that's cool. So we now have both. And we now move stuff around. So we'll now grab the Cyrillic files from the Latin directory and place them into Cyrillic one, and vice versa. That's why I didn't want to combine this logic here, because it would become, I think we should separate the responsibilities to separate two functions. So let's see. Now grab all of the Cyrillic ones and place them just a second. Okay, get all of the Cyrillic files. Get all of the Cyrillic files. Get all of the Cyrillic files. So Cyrillic files are going to be a combination of what? Whatever we have here. Whatever we have here. In the Latin path. We grab the elements from the Latin path. Let's find the same files for Cyrillic path. These are all of the file paths we have in both of those. And now that we have files in both of those, we need to filter into Cyrillic and Latin ones. So Cyrillic files are going to be, by the way, we need to make sure these are only the temporary ones. So we can now delete the non-temporary ones. We can now delete the non-temporary files. Let's see how we can do that. What's the best way to do this? Fair enough. This is destructive operation. And then we do what? We find the Cyrillic files. Are those that have Cyrillic? Just a second. Latin path, files, Latin directory. Okay. So those from this directory that end with so for files in here, if that file base name of the file, once we split it on the dot and grab the suffix there, if Cyrillic is in there, then that's a Cyrillic file, and we additionally add this for the Cyrillic directory as well. And then for Latin files, we do this. Okay, so we now have Latin files and Cyrillic files. And so now what we now do is, for safety, you could also move the files to another before deleting. Sure, that's true, but I'll comment it out while I'm testing, and then later it's gonna work. You're correct. We need some sort of protection. Let's see. What can I do here? So I want to merge all of the Cyrillic files into a single Cyrillic file. So I want to merge the Cyrillic files into a single Cyrillic file, and I want to do the same for Latin, and then I want to save them. We just have to keep track. We also have English, and that's always going to be a hard assumption here for now. So we can't mix up the order. I have to watch out for the order. You're a bold guy, accept that I make all the mistakes. I love to live dangerous. What can I say? So no, we shouldn't do this. We should do like this. Cyrillic files from Latin script. Cyrillic files from Cyrillic directory. And same thing here, Latin files from Latin directory. And Latin files from Latin directory. This will make stuff a bit easier. All of these need to be either 0 or 2. So for all these files, exactly assert that the length of files is 0 or the length of files is 2. Just codifying my assumptions here. Whoops. Okay, let's just leave it like this. Okay, that's fine. Okay, now we open the Cyrillic in the Cyrillic directory for English and for the Cyrillic target, and we just dump the lines. Okay, so now we do the following. We open what? We open the we just remove these, but we save their names. We go through the files. If it does not start with the temporary, well, we don't have to delete them. We're just gonna overwrite them. Which is also, we don't have to explicitly delete them really. So yeah, I think that's how we can do it. We don't have to delete it. If Cyrillic in there, well, it's a bit verbose, but listen, we can iterate. I just want to have a solution for a start. Whoops. So we don't have to do this deletion. We just split them. We just grab the and then we go for let's just make sure. So we're not going to open it up and override it. We're just going to open it up and override it. So let me see, how can we make sure that the first one is English and the second one is target? So the first one needs to be English. So the first one needs to be English and the second one needs to be target. What's the easiest way to accomplish that? A simple way would be if the 0th one. But this is such a cumbersome job. Base name. If that base name, I should have used path there, by the way. This can be refactored easily, but yes. So if this base name split dot grab the last one, if English is inside of it, then we do the following. we grab, this is the English out, English Latin path is this, and then let's just call it source. I keep on mixing English and source, oh my god. Latin path is this, and then we open with open English Latin path in write mode, which is going to destroy it. We are not appending as source file, and we open as target file. So we now open them up, and now what we do, we iterate, not exactly but almost, we iterate through the Latin files from the Latin directory. Let me see. No. We iterate, wait. We open the Latin files, so we have to iterate through the Latin files from the Latin directory and Latin files from the Cyrillic directory. Exactly. I messed up here. Cyrillic files from Latin. Cyrillic files from Cyrillic. Latin files from Latin. Latin files from Cyrillic. Latin, Cyrillic, Latin, Cyrillic. And so now we go Latin files from Cyrillic, or we just do like this. So what do? We open them up. There is a source, there is a target. We go through the files. Now the issue is these two are obviously contain both the English and the, so we again have to sort inside of them. Ideally, we could grab the English Cyrillic. Wait. This is not Cyrillic file. This should be Latin file. Latin file. Dude, I'm just gonna rewrite everything. I can't do it like this. So we go through the Latin files. But instead of doing this, I need to go in pairs. I need to grab the pairs. Let's just do it manually, and then I'm gonna optimize later. If length of this is bigger than 0, in that case, so if we have any Latin files from the Cyrillic, we pick them up, we grab the this is the out path. This is also the output path. And then now we grab these guys. Maybe. You do maybe. Target file is like this. We open them up. And we write to the target. Something like that. And then we do the same thing for, as I said, we're doing this manually. No, why are you so stupid? It's not, I'm looking for Latin files. Latin files from Latin directory. Something like this. That's the rough idea. Let's see. So if English is in the base name, okay, this sorting and stuff is kind of bothersome. Could I somehow always make sure that English is in the first location? If I sort that like that, then I don't have to do all these bothersome checks every now and then. Let's just make sure these are sorted so that English is always the first one. And same here. Let's make sure English is always the first one. And then this is going to be easy. So let's make sure these are the first ones. English needs to be the first one. English needs to be the first one. I'm going to make a helper function. Sort English files first. Given paths. This will work. Basically, we sort the path such as the key is if English is in X. Well, not really because X is a path, so we'd have to do OS path base name of that, and then we'd have to grab the split and then do this and then do this, and only then if English is there, then English is better. Okay, so this is gonna sort stuff, and now that we have this, we can just wrap up all of these. We always now know that English is gonna be first. We're gonna fix this later. For now, let's just get it to work. Okay. So now we don't have to ask. So we do the check. If English is there, no, we don't check. We just know. We know that English is first. And now we open those files. Okay. And then if this is non-zero, then we grab. No, we don't ask. We know this is English. So we have English and this one. We open them. We read from them. We go through the lines. And we write the lines. And we don't have to do this. Okay. The order doesn't really matter as long as we just paste stuff. And then if the Latin script has this, can we just do a for loop just to reduce this repetition? It does the same thing. Maybe we can. I think we can. We do something like this. We go through those files. So we have the, or we can just do something like, yeah, let's go like this, and then Latin files from Cyrillic Latin files. We just name this Latin files. And if Latin files exist, then we grab the first one, the second one, and then we just open them up. We read from them. English file, target file. Well, now we have a mix up here. We have a, this is gonna override this one. This is gonna mess up things. That's a subtle bug. Let's call this out, and let's call this out. And let's call this in. I don't want to refactor because maybe up there there's some similar names. And for some reason, VS Code is not really smart with refactoring. It doesn't respect the scope when I'm refactoring. Okay, I think this is good. So now, so we grabbed the Latin output path, we opened them up, and we said, okay, let's go through all of the Latin files from both the Cyrillic and from the Latin directory. If they exist, pick them up, open them up, read from them, and dump. And then we need to do the same for the Cyrillic. So we can potentially loop this again once more. And make it a bit more generic. So we go through 4 output files in, and we say this, and we say this. Then we grab this, and we say non-temporary. We just say output file is 0, output file is 1. We open them up, and then we read from. Now this is the tricky part. We need to dynamically change. We can't read always from the Latin files. We have to read through. Okay, we can just do the following. We can do tuples here. No, I think it's fine. Let's just give me a second. I think I can handle this one. It's gonna work. We just need to pass in this one here. And we need to pass in this one in here. And it's just gonna work nicely. So we just need to paste in this here, except that we now have to change this not from Latin files. We want to grab the Cyrillic files from Latin. So let's go like Cyrillic files from Cyrillic and Cyrillic files from Latin. Okay. And now we grab not just the output files, but we also grab the input files, and we read from the input files. We grab them, and they're not Latin files. They're just going to be current input files. And current input files, grab this, this, and that. I think this roughly works. This roughly works, and actually turned out to be concise, more concise than I thought. Okay, give me a second to just make sure this makes sense. Just give me a second, guys. Okay. I think this will work. Let's double check. So first assertion, source needs to be English. Then we have visited. We go to the directories. If it's file 0, that means we can skip that one because we don't have the data inside. Okay. Also, if it's visited, we skip. Let's see what visited means. So if we enter here, it needs to have 6 files. We grab the parent and then we find the children. We need to assert that this has at least 2. It needs to have either Latin or the Cyrillic directory. And then we just add all of them to the visited. So if we entered either Cyrillic or Latin, we will never visit the other one. We do this just once for the corpus, for the particular corpus. And then we grab the, we create the directions, source to target for Latin. We create the path and we make the directory. So that's now we are sure we have both directories. And next up, we grab the files from the Latin directory by just going to the Latin path and creating the paths. Same here. This could be done nicer with a path lib, but doesn't matter. Then we grab the non-temporary files. If it doesn't start with TMP, we put them here for both the Latin as well as for the Cyrillic. And then we do the TMP files, Cyrillic files from Latin, Cyrillic files from Cyrillic, Latin files from Latin, Latin files from Cyrillic. We do some assertions as we need to have either 0 or 2 of those. And then we just iterate. So we grab the non-temporary files, which are going to be the output files. We're going to override the old ones. So we start with Cyrillic and we start then, and then we go we start with Latin, then we go to Cyrillic. And then for the input files, we basically either have this, which means Latin files from either Cyrillic or Latin, or Cyrillic files from either Cyrillic or Latin. And those are the input files. So we go directions first Latin, output and input, and then Cyrillic, output and input. Okay, so we grab the output, and then we could have named this source as well. Even though the assumption currently is that it's English, we can change that later. Okay, just to make it a bit more. Okay. So we open that up and we open this up to paste both the English as well as the target language, whatever that is. And then we go through the input files, okay? And then we make sure that it has more than 0 because it's going to be a list. If it's more than 0, then it has 2. And so we grab the English file. We can put this again, source. We grab the target. We open them up. We read the lines from them. We iterate through those lines. And we dump that to the output source. Let me just change this. This should be... Okay, I have a bit of weirdness here going on because input, it should be input source. And then this should be source lines. And once we have source lines, we'll have source line. Okay, so input source file, input target file, read, dump to output source file, source line, output target file, target line. This is still open. Then we go through the next batch and we dump. And only then do we close. And then we go to the next iteration and we open up the next output files. And that's it. I think this should work. This should work. The only thing that we need to do to wrap it up is to delete everything other than all the temporary files need to be deleted, basically. So let's just do that. Go and find all the temporary files. So for TMP file in basically temporary files are all of these ones. In this plus this plus this plus this, we just remove the temporary files. Remove the temporary files. And here we grab partial data from temporary files and place it from temporary files and merge it. Okay. I'm fairly sure this is pretty much it. That was a long file. Welcome guys. I see there's a bump in the number of people who are watching. That's cool. For those of you who are new here, check out the Open NLLB channel. If you're new here, you'll find all the necessary context under the pin posts, including the language champion docs, including what's the project about, including the getting started, including the roadmap of the project, everything you need. But the TLDR is we're building a machine translation system that's going to be open source. That's going to cover 202 languages, and we're going to scale it up to like 3.3 billion for start, dense transformer, and then we're going to go even higher than that and also have other expansion plans, but that's kind of for the current scope of the project. We want to build open source empty checkpoints. That was just a quick note there. Okay, I see that Chris is writing stuff here. Let me see. Yeah. Okay, Chris apparently has a ton of experience training these. That's amazing. I trained 128K, 160 and 200 tokenizers. It was relatively straightforward. Sounds good. I assume the first models will not be the end all be all models, but trial and errors. Unfortunately, tokenizers require learning by trying as well, in my opinion. I think we need to do both and test using custom new HBS tokenizer versus SPM 200 would be a good learning experience. We can train the tokenizer. Let's see where we are with the progress here. There is a ton of data, 26 million. So we are now processing a ton of data here. Let me just see whether we can somehow make this a bit more efficient. The logic I have here with splitting, we prepared the line. We prepared the line by doing all of this. We replaced the Unicode punctuation, we removed the white spaces, we removed the dashes and the underscores, punctuation, digits, and then we retrieve back the line. We can't go past many of these steps, I think. Maybe these two can be somehow compressed into the other ones. My eye is crying. And let's see what else. So once we have the process line, we sum up, we go and see how many characters are Cyrillic. And then, yeah, I don't think we can speed up anything here. We have to go and do a for loop here. Maybe this can be optimized by not doing mapping and summing. Oh my God, my eye is dying. Something fell into my eye. And let me see. Okay, guys, I'm gonna go clean my eye before I lose it. I'll be back in a minute. Give me just a minute. Okay. I'm not sure what that was, but I'm alive. Feels good. Okay. Close that up. Go back here. 5 p.m. I have a meeting at 6:30. So we have 1.5 more hours to go. Or my battery dies first. I was saying we could potentially profile something like this. Let me see. We're going through the process line. Will this truly be a bottleneck? If this is in the dictionary, that should be an O-of-1 operation for dictionaries, if they are nicely implemented. And this is Python standard library, so it should be. In that case, we map that into a new sequence of true, and then we sum it up. Is that truly where my bottleneck is in? I don't know. I could quickly profile this and compare it with some other implementation, because this is kind of painfully slow. Although CC matrix, let me just see for Serbian language. I think CC matrix was the slowest one. Let me close up all of this Unicode stuff we were playing with before. Let me find the same here. And same here. For Serbian language, OPRS, here is Serbian. CC matrix is one of the biggest ones, but I'm not sure how big. Okay, it's not even the biggest one. The biggest one is going to be open subtitles. But the number of tokens, actually, it has more tokens, so that's what matters roughly. and NLLB is thus the slowest one. Okay. We can quickly profile that, and then we can test it, and then we have what? Then we are done with the classification. Did we add the right suffix? Let me see here. When we're opening up these files, okay, we have an error. I just noticed an error. We can't just use these output files like this, because, let me think. Because they might not have the right suffix for the directory they're in. Okay. I'll have to think how to fix that. Let's see, Serbian. So you can see here, Serbian Cyrillic. Okay. That's fine for Serbian Cyrillic. No, this will definitely not work. A couple of reasons. One of them is that we might not even have the files here. Cyrillic path. Some of these might be empty, same as these ones can be empty. These ones can also be empty. So we just need to remove these and then generate new ones. So we need to remove these and generate the proper ones. So let's just remove them. Let's make it a one-liner like that. Same here. And now that means we need to create a dedicated path here for Latin directory and for Cyrillic. Out files Latin directory and out files Cyrillic. Out files Latin are going to be, so after we create the directories, we can just create the out files here. They will be, go through the, no, not like that. They will be, whatever the corpus name is. What's the corpus name? Do we have the corpus name up there? Yes, there, but not here. Okay, let's get the corpus name. How do we get the corpus name here? Parent directory. Yes, parent directory, if we just grab the base name, we'll get the corpus name. Exactly. So once we have that, to generate these, we need to do join and then we need what? We need English and that. Exactly, that's what we need. So English, Latin, source Latin, and then we need out files Cyrillic path is gonna be goes with the elements, which are gonna be no, because this is English. We assume this is English, so we hard code this to this script, and here this goes to Cyrillic. Okay, this is not good. This now should work. There is some space to optimize this, not to optimize, to refactor it too, so that it looks like a decent human code, but yeah. I'm just gonna replace this, make it a bit more generalizable. So this always needs to be like this. The other one varies across Latin and Cyrillic because that's the name of the function, so that part can remain like that. And I think that's good. This should work. We now have to wait for the processing to complete. I think most of them are already processed. I would have, before we run this, we also have to make sure we're not messing up stuff. So that means we need to have like a validation that these final output files have the number of lines. Let's do some number of lines checking so that we don't mess up anything. To do that, let's see, count lines. We have some function for that already. Okay, and for the count lines to work, we just need to pass in the file path. That's it. So if we go back to analyze script, what's the invariant here? We want to make sure that the original files contain the same amount of data as what the final files contain, spread out across two scripts. To do that, before we remove them, we have to log the information, right? So we have to log the initial information. So original Latin directory size equals just a second. We place it here before we delete it. We go through the files. We count it up like this. We do that iteration there. And we count the number of lines. And we finally sum it up. We sum it up. Or we just grab a single one because it's a parallel corpus, and we can do something like this. So we can just do something like this, and then we do the same thing for here. assert that count files. Yes, we're gonna do that. Let me just see one thing. Will this support, if the path does not exist, will it work? I'm not sure. Because we might not have lines everywhere. So original size equals 0. Just add count lines, which we obviously need to import first. What's the name of that data set utils? Count lines. And same here. Sort after sorting. That's the original size. And now we want to make sure that these files are output files. I guess before we remove them, we can maybe do the check. New size. Number of lines should be a better term. Exactly. We just add for these output files. But these are gonna be, wait. We just need one. We just need one, like this. Like this, and then assert original number of lines. Okay, that's good. Just for the sake of robustness, let's also make sure that this has the same number. Whoops. Okay. Those are some additional checks that popped to my mind that we should do. And we now need to just step through this to make sure everything works. For that, we first have to wait for this to finish, which is kind of slow because we have a ton of lines. So it might take a while until we get to this stage, or maybe we can start. Maybe we can start and kick off a new run and just test it while this is running in parallel. So I think we can just do something like this and then pass in directory source and target. Directory source and target. We comment out this and let's just start and test a single one. Let's see whether this will work. So we can do it in parallel. I just start a new instance. Here we are. Let's see what's the first one we hit. The first one we hit is XLN, which I think we already processed, so we are good. So here it is. Let's start. So again, first assertion, we expect 6 files, 2 original ones plus 4 new ones that we got from splitting into Latin and Cyrillic. Okay, then we go up. So we go from current, we go to excellent root, and we find the corpus name, which is going to be, oh no, wait, this is already an error, because this should not be, this should be the path. Okay, that's how you debug stuff. You make mistakes. Stop this, remove this, rerun. Okay, exactly. No. Why is this? Why does this base name doesn't work? Okay. My God. Attempt number, is it 3? Let's see. Now it works. So now that we have the corpus name, so now we go and go through the parent, find all the children, and we have only one direction here, and that's fine. And we just add and we say, hey, we visited this one. And then we go and construct the 2 language direction. One is the English, Serbian, Latin. And then we just create that directory and we make it. See here what happens. Nothing now. And then the next, once we step over here, we have 2 directories now. So now we have 2 directories here. This is empty because so far we only had this one, and we have this one. Both English Latin to Serbian Latin and English Latin to Serbian Cyrillic. Okay. Next up, we create output files for the Latin directory. Here's how they look like. For the Latin directory, we have the English Latin and Serbian Latin. For the Cyrillic directory, we have what? We have, oh my God. For the Serbian Latin, we have the English Latin and Serbian Latin. And then we grab the files from the Latin directory, of which there is none. And here we have 6. Okay, and then we go. So let's pick up those which are not temporary files. In the Latin, there is nothing. And then we remove the original ones. So we can remove, okay, maybe better not do this now while we're debugging. So I'm going to just, or I can just duplicate this particular directory before we start playing. So we can back up. That's always a smart thing to do. Just create a copy there. Okay, so if we remove, now we can safely remove because we can always reconstruct it easily. So we removed the we didn't remove anything because this is empty. Now we go to the Cyrillic one. Here are the ones that start with TMP. Okay, this is messed up apparently. Of course it's messed up because these are the files, and we cannot, we have to find the base name, not this. I swear to God, I'm going to refactor this into pathlib a bit later. This, like, I now understand how sucky this OS path is, OS in general package. So we can't just do this. We have to be a bit smarter. We have to do base name. If that starts with TMP, and same here. Base name if it starts with TMP. Okay. So that was a bug. Luckily, nothing happened, no destructive action, so we can just continue where we stopped. Rerun quickly. Okay. We have them sorted. English first. Or actually not, it did not work again. Because this probably also assumes something. This should have changed it in place, but he did not. If it starts with temporary, then put it, if it doesn't start with temporary, put it here. Okay, it doesn't start with temporary. And then we sort them. And English should be first, but it's not. Why? Oh. Could it be that, let me just a second. Base name split to get the last part, and if English is inside. Well, we're gonna put the breakpoint there and restart again. Let's rerun this. Okay, here we are. For empty, it's easy. Let's run again. So paths. Again, for the paths, the first one is now... The first one is English. Aha! Okay, it's actually sorting the... We need to put... The bigger ones go later. So we need to put if English 0. Otherwise 1. That was the error. Now it should work. Rerun. Rerun. Sort. Now English should be first. Yes. Let's go. So, we count the lines. And we grab just one of them. And then we remove both paths. So here, what we are left with is no original files, just the shards. Now we pick up Cyrillic files from Latin. Nothing. Nothing. Cyrillic files from Cyrillic. Should have 2 of them. Latin files from Latin, nothing should be there. And finally, Latin files from Cyrillic 2 should be there. Exactly. And then we just assert the assumption. All either 0 or 2. And final step. We go here. We grab the output file path. It's going to be Serbian Latin. And then for that direction, we grab the English one. It's going to be the excellent English Latin. And then the target is going to be Serbian Latin. And then we open them as in the right mode. And then we go through the input files. Okay, here are the input files. English Latin, temporary, and Serbian Latin, temporary. Both of those are in the English Latin to Serbian Cyrillic directory. If they exist, which they do, we grab them, we open them up, we read them, and now line by line, we are basically writing this back. And then let's go back to here. And now this should be empty. Oops. I don't want to move you, I want to move this one. Now you should be empty. And so we skip. And so we go back. And then we write to the Serbian Cyrillic. Wait. This was for the Latin directory. The last one was for the Latin directory. Okay. And now we write, let me just double check. Okay. Go back. Whoops, go back here. Now we do Cyrillic, Serbian Cyrillic, and English Latin still. So we open this up. This is data from English Cyrillic, quote unquote, Cyrillic, and Serbian Cyrillic. Will that actually work? Yes. Even though English can be Cyrillic, this is just a minor thing we currently have as an implementation detail. And so we pick up quote unquote English Cyrillic and Serbian Cyrillic, and we write those back in here, and then we hit F5 until we get here again. And this should again be empty. Wait, again, this one is kicking off. Okay, so now we have here again empty, and so we do nothing, and we do nothing, and we're done. And so here we now count the lines, and we assert they are the same number. And they are. And then we count the lines for the Serbian side. So Serbian Cyrillic there, Serbian Latin there, and then we compare that as well. Original number, new number, and that's the same. And finally, we remove the temporary files. Ta-da, that's it. And we have a clean, excellent. So we now have separated Serbian, English Serbian into English Serbian Cyrillic and English Serbian Latin. Let's just make sure this makes sense. This is indeed Cyrillic. This is indeed English. And they have both the same number of lines. 1076357, 1076357, 398,104, 398,104. Okay, I'm gonna do a bit more testing there, just in case we messed up something, but so far it looks good. Let me now stop this run. And let's kick off this second one. This second one is hitting the breakpoints because we refactor the code. It's still assuming we have the old code. So it's just stopped on the random place. Let's just let it run and see what we have now. We are processing CC matrix now. So that's working. Okay. We've done this. And we fix this. Just test that the Cyrillic / Latin splitting logic works as expected. That's going to be the next task. Other than that, we can start the deduplication process. Let me just see. One thing I want to fix is I don't want to have English Cyrillic. That's obviously very bad. So what we want to do here is when we are outputting those temporary files, we have the target source. This should be, for the source should be Latin. Always Latin. Okay. So that's gonna fix the issue there. So we're gonna save there, and then that doesn't change anything because we never filter based on Latin. We just try and find the English. prefix. Okay, guys. Let's go to analyze script, analyze data, and let's run dedupe. So I'm going to now run the deduplication for first local deduplication for analyze data for Croatian. We did kick it off before, but I think I stopped it accidentally. Analyze data, just kick it off and wait until we hit the breakpoint there. Will this work now? Just a second. Will this work now? Oh, it will, because this is Croatian. For Croatian, we're not splitting into Cyrillic. Okay. Run. Let it run. Some issue with the launch arguments not being passed in correctly. Let's see, what are you complaining against here? Analyze data, dataset root. Maybe I messed up the, wait, maybe I messed up the analyze data accidentally. Let me see, what did I change here? Nothing. So what are you complaining about? The following are required, datasets root. Well, I did pass that in. Aha, okay, I forgot to change this. So we have to change this to analyze data and now kick it off. Okay, run. Found 174 files. I have some shoulder ache. I've been working out too much and I guess the computer work is not helping. Number of language files we found. Why is it not progressing? We need to add some type of progress here always. Yeah, because in the first one it was running, but it didn't log anything. So what we need to do here is put in TQDM around the zip and just put total, and total should be, what's the total? Well, whatever the count line is, that's true. Just a second. TQDM total. How do we know the number? Did we already compute that in this particular file? Number of sentences is just, well, we'll have to do this. That might slow us down though. It's not computed up there. That's why I have to run it there as well. Okay. We're making progress either way. Small break, I have to eat a bit. I just had a breakfast and I have a workout a bit later. Let me wrap up this prosciutto from Montenegro, the best thing ever. Maybe Spanish and Italian are better, but while this is running, This is basically measuring the number of duplicates inside of the dataset itself. But we also care about the global deduplication, because some of the datasets might have overlapping sentences, and in case they do have it. I meant indeed they do have it, I already checked. Okay, I'm done. Let's see how the other code is working. What's up here? Parse new arguments. What was this? We are still running this. Okay, CC aligned. Okay, that's kind of blocking. So we are waiting both for deduplication as well as for this code to wrap up. Until then, let's see what we can do. We're running this. We're running this. Let's see a bit more about what Chris mentioned about tokenizers and see what we can learn there. Let me just first update them. Let's see this. I recommend either 1% sampling of all your representative data or the open LID data set. Let's check what it is. I prepared it into Hugging Face. Okay, with a 20 gigabyte corpus, max 24 to 48 hours. Let's see. What's our dataset size currently? We have around 100 million sentences for each of the languages, which means around 300 mil in total. Let's see what that translates to in terms of gigabytes. So Croatian has, let's see how, 13. So I guess we have roughly, in total, we have around 40 gigabytes. Maybe even less. Let's see if it's not the same. 13.4 here as well. Serbian might have a bit more because we have redundant files. Yeah. So roughly 40 gigabytes. And then obviously we will not be using 100% of that data. So I think we fall roughly in the category that Chris is mentioning here, if not less, because he was probably training on more data. Max 24 to 48 hours on 128 vCPUs on a 1 terabyte cluster, $50. There's a lot to consider when training a tokenizer. White space, digit, punctuation. So if you don't want to go through that, you could skip by SPM 200, but as you've said, it is, so that is rigid. Yeah, that's true. Let's open up this one. Let's see what it's about. OpenLID dataset. Fast natural language identification for 200 plus languages, plus all the data to train the model. Supports 201 languages. High performance, fast and easy to use. Okay. Is a fast text model. That's from Meta, right? I think Meta uses fast text. GitHub. Yes, Facebook research. Okay. To download and decompress. Example to get most likely labels. Okay, let's do this. We don't have the LID yet in our pipeline, and we do need to add it. So let's play a bit with this, just to see how many sentences we have in like Bosnian that are, for example, English, etc. I've seen Turkish as well in Bosnian. Download the dataset, roughly 20 gigabytes, and convert it to fast text training format. TSV. Each tab separated line consists of a sentence in one of the 201 languages, a code for that language, and a script, and the source of that line of data. The classes in the training dataset have been sampled to help ameliorate this class skew. This means that the larger classes have been subsampled and the smaller have been upsampled. Open use for non-commercial purposes is covered by all licenses. Okay, a ton of different data sets. We are using some of these in NLLB as well. pick Z, decompress it, write to standard output, pipe that into this. Sets the field separator to tab. Print label. It prints a modified version of each line from the input. Specifically, label 2 adds the string label followed by the second field column from the TSV data. Oh my god, it literally knew it's gonna be used for fast text. Wow. Where a label prefix is often used to indicate a label category. Appends a space and then the first field from the TSV data. And then the output of the previous command is redirected. Decompresses a gzip TSV, processes its content to format it with the label prefixes and saves the modified data in a TSV. Nice. We did before use, is this OpenLID used here? Let me just check quickly. We did have this one. This one is actually from Facebook directly. I think we were using this one previously. Language identification. It was introduced in this paper. Okay. Did NLLB use this one? Yes. And the hosted version was released as part of the NLLB project and can detect 270 languages. How does this one compare with that one there? FastText is an open source free lightweight library that allows users to learn representations and text classifiers. It works on standard generic hardware. It was introduced in this old paper, and the official website can be found there. It says 218. As if it supports 218, not 270 languages, but anyhow. Okay. Can be trained on more than 1 billion words on any multi-core CPU in less than a few minutes. That's amazing. How many what's multi-core? On any multi-core CPU, a single CPU. It includes pre-trained models trained on Wikipedia and in over 157 languages. Mikolov back in the days when word to whack was a thing. Okay, and we get what we predict, and it says label English Latin with this probability. K5, it gives you 5. Train on common crawl in Wikipedia using fast text. Bag of words. Use the stamp for this word segmenter for Chinese, MACAP for Japanese, and UET segmenter for Vietnamese. For languages using Latin, Cyrillic, blah blah blah. They use the Europarl. Non-commercial 4.0. Okay. Let's quickly understand how this works. There is a chart or diagram or something. Hello, welcome back. We're running this in the background. Let me see how it's progressing. It's running the NLLB, which is the biggest data set, so it might take a while to process this one, but we are almost ready. The word vectors have dimension 300. For each positive example, we sample 5 negatives at random with probability proportional to the square of the unigram frequency. We use a context window of size C and uniformly sample C between 1 and 5. In order to subsample the most frequent words, we use a rejection threshold. When building the word dictionary, we keep the words that appear at least 5 times in the training set. The step size is set to 0.0525. Okay. And what's this one? Okay, it's again just a fast text model. So what's the difference between this one and the other one? There is no comparison, nothing mentioned. Let me just ask Chris quickly. Oh, nice. Let's see. Oh my God, 6 million duplicates. And those are exact duplicates. That's from the open subtitles. Oh my God. That's gonna be like the extreme power law. 1.8 million in CC aligned. 0.5 million, and everything else is it's just a dramatic power law across data sets. And it's gonna be even more crazy for, and by the way, this is when both the source and the target are the same. So both the source and the target sides are the same. Dedupe the pairs. So we are deduplicating the pairs. Dedupe the pairs. If dedupe the pairs, then we do here. We normalize. If it's not none, we normalize it. And we do a line hash. We literally do a line hash. So it's not even fuzzy. There's gonna be if we went fuzzy, who knows how much we would filter out. That tells you how low quality open subtitles really is. What does this function do? Let me remind myself. Strips, lowers digits, and removes the punctuation or non-printing characters. This is actually what we wanted for. This is actually what we wanted for our code there. Non-printing characters. Yeah. We might want to paste that as well. Let's grab this. We're gonna save that to the NLLB script. We'll need this. And punctuation or non-printing. Okay, and then replace the Unicode punctuation. Just a second. Just sub that one, Unicode punctuation. Okay, I'll have to check how this one is used exactly. Okay, I'll just tell it to do here. Go back to analyze data. We are here. Let's see how we stand with the duplicates. So now print this whole thing. No, what happened? What happened? No. Well, We already saw what the result is. Number of sentences, line lengths, we don't care about those, we just care about the dedupe. We can always save it. Where did I subscript it? What's wrong with the... Something got terribly messed up there. I'm gonna just save this. So grab this one and store it. Store the default tick. Python. Save the default tick in Python. Maybe something like this. Save that. And we can open it up from a different program. Just grab the path and we're here. Almost. Kick this one off with no arguments. Make sure this works so we don't lose the data. It did take us a while to get here. Okay, is it working? Run, yes. Okay, here it is. Aha, this is failing, apparently. Aha. Rerun. And those are the numbers there. Can we somehow make this a bit more readable? What will this look like? What's going on? I hate this. What's the best way to just save this without having to struggle? I remember I've done this before as well. Well, we have the data. Okay. We now need to do the global deduplication. Let's see how we can do that. Just saving the data for the deduplication numbers for different data sets for Croatian. So I just saved it, and now I'm just trying to load it up but it's this weird pickle file, so like I kind of saved it in a very nasty way, so now you can't really iterate through it without, what's the type of this? Type of P, not even defined, it's completely messed up. Just a second. Type of P is a numpy array. And then, so we created a numpy array that's that has dictionary inside of it. Let me just see. Extract dictionary from numpy in Python. We might be able to do something like this. P item. And then, okay. So we might be able to do this, and then this is type. Okay. Okay, this might work. Stop this and rerun. And then this is default dictionary. Ugly, but we have the data. I just wanted to make sure we're not losing the data. For different data sets, we have the number of duplicates here. It was more FYI for me, like to understand roughly how the duplicates look like across data sets, and here is how it looks like. As we confirmed already, as we stated, we had a couple of these data sets which have a massive number of duplicates, like Open Subtitles was one of them, and then CCL line had 1.9 million almost. Let's see till the very end. Let's just remove this. And 6.5 million here. Yes, 6.5 million in a single data set. And it's like, it's not just a duplicate on only the source or the target side. It's both the source and the target are repeated 6.5 million times. It might be because those are subtitles. Sometimes it's like literally thank you and stuff like that, which is always the same. Okay, let's go to analyze data. And let's now do something different. Grab the filter. And instead of here, we actually want to put it, we want to make a global one. Before and after. So what we care is only going to be this. We don't care, we won't care about, just a second, what makes sense here? Global duplicates. We shouldn't add, no, we shouldn't add, wait, just a second. We just need to see at the end what's the difference between total after and total before. That's all we need. We need to move this outside temporarily because we're dealing with global. I'm just gonna do something like this. It's gonna be hacky, but it will work. If we have it there, in that case, This is just always going to be reused. And then at the end here, I just want to print all of this. Okay, guys, I'll have to wrap up the stream also to grab some rest. I'm getting less productive now that I'm tired and my shoulder is killing me, and I have a meeting in 15 minutes. I'm gonna make a break, but I'm gonna run this while we are on the break. This will be running. So dataset counts. That's everything we need, really. Let's kick it off. Let's see how many duplicates we have in total here. So set this to analyze data, kick off the run, wait until we hit this. See how this is going to look like. Nice, we have TQDM now. Okay. On the other hand, we have the script here. Let's see how it's running. We are still processing NLLB because it has like 26 mil. A lot of data here to be split. Okay, guys. Catch you later. Catch you after the break. Roughly 8:30 p.m. And then we're gonna continue doing this, analyzing the tokenizers and everything else, guys. Cheers. Have a nice day, evening, morning, wherever you are, and catch you a bit later if you're coming up for the next stream. Bye, guys. I recommend you use black for the formatting. It's so cool. Yes, I did use black before for some things. 100%. See you guys. Cheers.